All right, folks, it's bass action, back in action. In this video and the next video, we're going to talk about trigonometry and our basics of trigonometry. When you get to pre-calculus, you'll take this much, much farther, but we're just going to start with our basics and what we'll be doing with it in geometry. So before we jump into some actual examples, let's get an understanding of what exactly trigonometry is. And before we do that, we need to discuss this part here up at the top, this before we begin. All right. When we're working with our trigonometry, there always needs to be a point of perspective. We need to communicate that. And often you'll hear me say, if you're sitting, let's say, in a classroom and one person is facing forward and one person is facing backwards, your perspectives of the room are going to be dramatically different. How you would describe what you're seeing is going to be completely different. The same thing is true about our triangles. So there are some phrases that are used in trigonometry, and those would be an opposite leg. We just usually say opposite, an adjacent leg, and we'll just say adjacent, and then of course the hypotenuse. Now those are all going to change depending on where in the triangle you're standing. Now obviously we're not physically standing there, but that's what we're going to think about it as. So let's just say on this first one that I'm standing at angle G. From angle G, of course, the hypotenuse is never going to change, so I would label that as an H. And then the opposite leg would be directly across the triangle. And then the adjacent leg would be the leg that also helps form angle G. Going on to A, if I'm looking, let's say, E is my perspective. Again, the hypotenuse never changes. The adjacent leg, let's do that one first this time. The adjacent leg, again, is the leg that helps form the angle where we're standing. And then the opposite leg is directly across. And we're just going to call those opposite and adjacent. And then if, let's say, angle T, and we'll have our hypotenuse, it's always across from the right angle. We have our opposite and we have our adjacent. Now, what you might notice here is that the angle that I chose was always one of these acute angles. You'll notice that in none of my examples did I choose the right angle. For our purposes in terms of geometry, we will never use the right angle as our point of perspective. When you get to your trigonometry in your pre-calculus classes, you'll actually learn how to handle that right angle. Okay, now let's take a look. What exactly is trigonometry? The simplest way to describe trigonometry is simply a tool used to find measurements in triangles, and those measurements might be angles, and those measurements might be sides. It's based on the knowledge that if two triangles are similar, then the ratio of their corresponding sides will always be the same. So, for example, let's look at these 30, 60, 90 triangles that I have going on here, and let's say that we're going to use this 60-degree angle as our point of perspective. Okay, if let's look at the inside triangle, and I could call this, let's say, hypotenuse 1, and this would be the opposite leg, and I'm going to say sub 1, and I'm going to say the adjacent leg sub 1. And then if I looked at the bigger triangle, again, I'd have a hypotenuse, so this time I'm going to call it 2. I'd have this other opposite leg, I'm going to call it 2, and this adjacent leg, and I'm going to call it 2. So based on those two triangles, what we would know is that the adjacent leg from triangle 1 compared to its hypotenuse is going to be the same as the adjacent leg in triangle 2 compared to the hypotenuse in triangle 2. Now, if this is a 30, 60, 90 triangle, as I've had it labeled, then what we can do is we could actually put some measurements on that, okay? So we know in a 30, 60, 90 triangle that the short leg across from the 30-degree angle can be labeled as a 1. We know that the hypotenuse can be labeled as a 2 if we thinking about our extended ratios. And then the long leg we would label as a square root of 3. Which means that if we wanted to continue thinking we're standing at the 60-degree angle, then no matter which triangle we're looking at, if we compare the adjacent leg to its hypotenuse, what we would get is a 1 over a 2, okay? Now, what we know is that's going to be true for any 30, 60, 90 triangle. Okay, now a trigonometric ratio, this ratio, remember ratio is just a fraction. A ratio is going to compare the lengths of two sides of a triangle. Now, mathematicians have identified 3 specific ratios. We can certainly understand that there's a lot of them, but there are 3 specific ones that we're going to talk about. And those 3 are called sine, cosine, and tangent. Okay? Now, it is important that we always have an angle, just as we've been talking about here. So what they've done is they've given them these shorthand names, sine, cosine, and tangent. And when you look at your calculator, what you'll find is that sine is abbreviated SIN, cosine is abbreviated COS, and tangent is abbreviated TAN. So if you have a scientific calculator handy, you can go ahead and pull that out and find those buttons on your calculator. Now, sine, we need to give an angle name, so I'm just going to pick a letter and I'm going to say it's angle B. And sine will be the opposite leg over the hypotenuse. So sine is a shorthand way of saying, hey, go look at your right triangle and compare the opposite leg to the hypotenuse. And that's what this O and H right here is. Cosine then, let's say of angle B, is going to be an adjacent leg over a hypotenuse. And tangent of an angle B, I'm just picking an angle B, it's nowhere necessarily in our picture, we're just picking it, is going to be the opposite leg over the adjacent. Okay, so there's the O and the A, and there's the A and the H. We call this SOHCAHTOA. You'll hear teachers talk about this a lot, SOHCAHTOA. Okay, that's just our shorthand way of remembering that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And I have this here again as a reminder that it is important to always give an angle measure or a name so we know and can communicate where we're standing. Now, what I've done here is I've looked at specifically a 30, 60, 90 triangle, but let's look down here at the bottom and understand how this is helpful. We know that there are lots of triangles in the world besides just 30, 60, 90 triangles and more angles that are just 60. So what mathematicians have done is they have actually gone through and they have actually determined what these ratios would be for every single possible angle that exists. Now, before we had our scientific calculators, okay, people would use what's called a trig chart. And I have a small portion of a trig chart over here. So what we want to think about is that up above, when we were looking at our 60-degree angle, so let's take a look here. So we had our 60-degree angle and we compared the A over the H, which means we were doing cosine. We were doing our cosine of 60 degrees, and we found that it was this 1/2. Now let's take a look at our trig chart down here. So what we would do is we would identify the ratio that we're wanting to look at. So we would, let's say, find our cosine. So we'd find the cosine column, and then we would follow that column down until we got to 60 degrees. So we'd look at our 60 degrees, and sure enough, then our cosine of our 60 degrees is our 0.5. And that's exactly what we wanted from up above. It is our 0.5. So yes, that works. That's exactly what we wanted. So let's just try another one. Let's say we wanted to do the sine of 52. Now, students often want to call it sin, but it is called sine. So we would go to our sine column, and we would go to our 52 degrees, and we would find our ratio right here. So we'd get 0.7880. Okay. Of course, we could go backwards, for example, if I wanted to know the measure of a particular angle. Let's say that I knew that the tangent of some angle was 1.5399. I could go to my tangent column, and I would go down that column until I found that 1.5399, and sure enough, it's right here. And then I would follow that back and find that, oh, it's 57 degrees. So if I know that the ratio of the opposite over the adjacent, the opposite leg over the adjacent leg is this fraction, then the angle I'm standing on must be 57 degrees. So we could do one more. let's go back and we'll do cosine. So let's see if we can go down our cosine column, and oh, right there's our number that we were looking for. There's our 0.6947. So the angle must have been 46 degrees. So if I'm standing on an angle and I compare the adjacent leg over the hypotenuse and I get 0.6947, then the angle I'm standing on is 46 degrees. Now, we do have scientific calculators. So if you have your calculator handy, what you can do is you can type in this expression right here. Type in sine 52, and you should get 0.7880. Now, don't be too worried if you don't get this number. So if you can find the button and you type it in and you don't get that answer, just maybe dog-ear this page and let's talk. It just means that your calculator might not be in the right mode, or I just need to show you how to type it in specifically for your calculator. Now, we can also go backwards. So just like we did in our chart, and if you want to type it in your calculator, just give it a try before you come to class. Instead of typing the tangent, we're going to type this tangent, and it looks like an exponent of -1, but it really means an inverse. So see if you can find that in your calculator. Again, if you can't, I'll show you in class. And then type in this 1.5399, and you should get 57, or really probably a decimal that rounds to 57. We could try it here with the cosine as well. Again, give it a try. If you can't figure out how to do it in your calculator, it's okay. I'll show you in class. But the more you can at least try a little bit before you come to class, it'd be a good thing. So if you want the angle, we're going to type it in with this inverse, this -1, and see if you can type that in and get your calculator to say 46 degrees. Okay, now on the next page, we are going to do some examples and see how this applies to our triangles.